Hello. Here is the third example of endogeneity. I call this simultaneity or reverse causality, or you can think in many different ways. So typical example is price and quantity, but let me think about this. Interested in the effect of internet speed on GDP growth. Say, Y is GDP growth and X is internet speed. But at the same time, so when you write down this regression model, it means that higher internet speed will improve GDP growth by beta. But on the other hand, the problem here is you can set the relationship the other way. Because you make more money, your GDP is high, your internet would be high, fast, right? So it is not. It is the GDP growth that enabled fast speed internet. That makes also sense. It also makes sense, and so X affects Y, but Y affects X at the same time. So you have two equations at the same time. You need to consider them at the same time. So in this case. But suppose that you ignore the second equation, but only the first one, and these are, if you use these two equations and solve for the answers, these are the equilibrium. So observed equilibrium x and y are given this way, and then if you see this, x depends on epsilon. Epsilon is the components, unobserved components of GDP growth rate, other GDP determinants other than internet speed, like say oil price, for example. And then oil price affects your internet speed because if your economy is doing well, then that will increase your internet GDP speed. Internet speed, and higher internet speed again increases GDP, and then again increases speed. So in that way, at some point there must be equilibrium, and it depends on epsilon. So clearly x and epsilon are correlated. So in the end, because of this, if you consider only one regression model, there is some problem. There is the identification breaks down. That is the problem. And the last example is the measurement error assumption. I have explained it earlier. Say Y is wage, X star is the true intelligence. So I put star because true intelligence is not observed. So your wage will be determined by your true intelligence, but it's impossible to measure how smart you are. But alternatively, I may use your test score. Say your econometrics grade is an approximation of your intelligence, but it's not perfect. I understand it is not perfect. So I allow that econometrics grade is your intelligence plus measurement error. There is some measurement error. Then let's think about this model. The true model is given this way. Your wage is originally, the true relationship is with the true intelligence. So it is the true intelligence that affects your wage. But you do not observe this. So but in your data, what you can do here is wage and test score, econometrics grade. And then you can show that if you plug in this relationship into here, and then you are going to get, there is a typo. You are going, is right. So you are going to get beta equals to gamma. Beta equals to gamma. That is nice. So because if you could estimate this regression equation correctly, if you could identify gamma, then you get beta, even if you don't observe X star. However, the problem here is the correlation between x and epsilon, because this epsilon is written in this way, and clearly u is included in here and here. So the measurement error, epsilon includes the measurement error, some of the measurement error, and x also includes some of the measurement error. So because of the measurement error, they are correlated, and x is endogenous. So these are the examples, and this is it. I think this is it for today. And I am going to, I post homework 1, and before this lecture, I believe you have watched Leak's demonstration to the homework. And next time, I'm going to use a serious model to discuss the endogeneity problem. See you later.